This conference will now be recorded.
Hello students, very good evening. So today's class will discuss the system of particles and rotational motion, basically questions from JEE mains exam. And in today's paper, today's discussion, we will discuss how to calculate center of mass for various systems and related problems from JEE paper 2019. 2019. So these are all actually maximum problems are from 2019 we are discussing today. Okay, so let us read the problem and try to solve them. So the first question is given here: a uniform rectangular thin sheet ABCD. A B C D. This is a uniform rectangular thin sheet. That means thin sheet means it has some mass throughout, and this whole sheet has mass capital M and length A. As you see, this is A. From the coordinate you can see 0 A, so this is A, and breadth, that means this one, this is B. So this is given in the figure. You can see this shaded region HBGO. This shaded region, if cut off, then what will be like, what are the center of mass coordinates for the remaining portion? Okay, in the, see, in this figure you can see that if I just consider 4 equal parts, so when this part is removed from this whole sheet, then what will be the center of mass coordinate of the remaining portion? That means this portion is not there. If you ask me to draw properly after removing the portion, then I would draw so this portion is not there, right? Equal portion, say this goes up to here, so these portions are there, only this portion is not there. Okay, this dotted portion. Okay, otherwise you have this configuration. Now for this configuration you can see this one, this is the configuration. For this configuration, where will be the center of mass coordinate? This is actually very simple. It is uniform rectangular coordinate, rectangular thin sheet. So if we just consider the whole sheet, and whole sheet has mass capital M, right? This whole sheet has mass capital M. So if you have the whole sheet, where would be the center of mass? See, if I have the whole rectangular sheet, the center of mass will be at the middle point. Okay, that means this coordinate will be A by 2 and B by 2. Okay, if you take this coordinate 0 and this is A, this is 0, this is B, like that, then this point actually will be A by 2, A by 2, and at the middle of the thin sheet, as you can see here. So O is actually center of mass when the whole sheet is there. Now this whole, from whole sheet, this part is taken away. So you look here, it has breadth B by 2. This particular shaded region has breadth b by 2, length a by 2. So if we wish to calculate the mass of this particular portion, we can actually calculate. How? The whole mass for equal 4 equal parts will be what? So let me just tell you. So this has certain area, right? The whole mass is capital M. So mass per unit area will be A into B. So M by AB, mass per unit area, into the area of this particular part. Area is actually A by 2 into B by 2. Of that particular portion, the area is AB by 4. Now A, B, they will go off. So mass of that particular portion is capital M by 4. Okay. So this particular portion has mass M by 4. Look, when this whole rectangle is there, uniform rectangle, then the center of mass is at the center. Now if I just consider this small rectangle, now it is more like a square. Let me just remove this. So if you have this rectangle, then also the center of mass will be at the middle point. So what is the center of mass of this chopped portion or the shaded region now? So this is up to here a by 2. So up to here another a by 2 will be added. Okay. So sorry, a by 2, and this is a by 4. So a by 2 plus a by 4, then only you will get the coordinate for this. So you get actually 3a by 4. Okay, 3a by 4. Similarly, in the y direction also, this is b by 2. So this will be 3b by 4. So this is actually the coordinate of center of mass only for this particular portion. Okay, only for the shaded region. I'll just tell you. So here for the chopped portion, the center of mass coordinates are 3a by 4 and 3b by 4. Okay, so let us say this is O prime. So O prime has coordinate this, and O had coordinate A by 2 and B by 2. This was the original coordinate. Now, if you want to calculate the center of mass XCM, let me go to the other page. So XCM you have to write M1, let me write in small case, M1 X1. Okay, so in this case you can consider there are two particles. Now you can consider there are two particles, one with this and another one. So one has mass M. Okay, one has mass M and another one has mass M by 4. I'm sorry, not M. Yes. So M, we have to now write down the center of mass equation, coordinates of the center of mass we have to write. So M1 x1 minus M2 x2 divided by M1 minus M2. Okay, so look what I have done here. I had 4 portions. So this portion alone has mass M1 and others are M1, M2, M3, etc. Say, sorry, this M1 is suppose this portion, the remaining portion M1, and this portion is M2 is only this shaded region. This is M2. Okay, so M1. What is X1? X1 for this is A by 2, right? This particular portion was A by 2, and this has m2, that means m by 4, and what is x2? X2 is actually 3a by 4. Here m1 was actually capital M, we can say, or sorry, this is m m a by 2. Okay, total mass m divided by this mass is total mass is m minus m by 4. This will be x coordinate. If we just solve it, see this part is actually m1 x1 means suppose I have the whole mass here m1 and coordinate x1, and here you have the mass of this particular portion is m2 and the coordinate is x2. That is what I am calculating center of mass for this particular point masses. So that is what we are doing. So in this case all the laminar, like if all were there, the center of mass will be here. So this I can treat as a point mass having the whole mass of the lamina. And here this particular shaded region or this particular portion has mass now m by 4, and it can act as a point particle having like it has a position coordinate 3a by 4 and 3b by 4. So from there actually we are doing, so you can just uh, do the calculations. So a by 2 and 3a by 16. Let me just go with this, and this is 3m by 4 already. So this will be 8 minus 3, so 5 by 16 a, and here it will be 3m by 4. So 5 goes here, 4 goes here. This is a divided by 16 into 3m. Okay, 3m, m up and down will go away. M will not be there anyway. So now this is 4, so 5 by 12a. Okay, so 5a by 12. This is actually, or 5 by 12 into a. This is found to be the x coordinate. Similarly, if we calculate for the y coordinate, y coordinates in the same way we can do m1 y1 minus m2 y2 divided by m1 minus m2. So m1 means m again, and y1 means b by 2. Similar calculation actually. M2 is again m by 4 and y2 is b by 4, and this is m minus m by 4. So we have got one coordinate. I will just erase this part. The answer was 5 by 12 into a. So in this case the calculation seems same, so this also will be 5b by 12. Okay, 5b by 12 or 5 by 12 into b. So we have the coordinate, center mass coordinate 5 by 12, and this is 5b by 12. Okay, so these are the coordinates now. You can just go and compare with the options. So this is the correct option here in this case. Okay, 5a by 12 and 5b by 12. So this is how in this case actually one point is very evident. You can see we have to just consider this kind of structure like a rectangle. We should have a actually approximate. We should have an approximate center of mass for the whole lamina that has a center of mass at the middle. So this center of mass can be treated as a point mass of capital M, or the whole mass small m I had taken here, and the coordinate will be a by 2. And this has some other particle which is center of mass here, uh, and it has a coordinate 3a by 4 and 3b by 4 like that. So now you have to calculate the center of mass with respect to these 2 point masses. Then things are all right. Here, why minus I have taken instead of taking positive over here? I should have taken positive, but I have taken negative both side, both numerator and denominator, because this is going to be going to add nothing. That is actually that shaded region is actually cut off from the thin lamina. Now, this you might have already seen. Actually, these are all so far whatever we have discussed and what I am going to discuss. These are all from JEE mains paper. JEE mains. Two 2019 paper. Okay, so we'll move on to this question. See, here there are 3 point masses M1, M2, M3. They are actually situated at the vertices of an equilateral triangle of side 1 meter. The coordinate x, y of the center of mass will be what? So what will be the center of mass coordinate? You have to find out that. So in this case anyway, there are 3 masses, you know that, and these masses can be treated as point mass. And their coordinates also you can find out, since it is, see, this point is the origin 0 0. This is the x-axis, this is y-axis as shown here. So if you want to calculate the coordinates, see, M1 has coordinate 0 0. What M2 has? M2 has, suppose some value a 0. Okay, or here it is 1 meter, so I'll write 1 meter itself, 1 meter and 0. M3 has coordinate 0.5 meter. Okay, 0.5 meter. And in the B direction, oh sorry, in the vertical direction, it has height 3 3a by root 3a by 2. Okay, so we have got the coordinates. Now we can easily find out the center of mass coordinate, and we know how to calculate. So let us do the calculations here itself if possible. So if I write center of mass coordinate, let me go to the next page itself. So we have to write m1 x1 plus m2 x2 m3 divided by m1 plus, so here there are three particles, so I'll keep as 3. So now if we just write the coordinates, then it will be giving you the right answer for this center of mass. So what is m? M, whatever m may be, x1 is 0 because it is situated at the origin. So nothing to do with this. This part will give you 0 anyway. So this part is 0, and m2 we have to check what is the mass. M2 has mass 100 gram, that means 0.1. So M2 M2 is 0.1 kg and X2 is 1 meter. Kg, this is kg into 1 meter. And M3X3 M3X3, we'll see what is M3. See here M3 150 gram, that is 0.1 kg, and this is the height. Okay, that is what we have to write. 0.15 kg. M3 X3 is A by 2. That means 0.5. This is so M2 is M1 is 50 gram, M2 is 100, and M3 is 150 gram. 150 gram. Okay. So M1 is 0. M2 so mass is 0.5, 0.1, 0.175, and M3 is 0.175. M3 X3. M3 is this, X3 is X3 is root over, sorry, this is actually A by 2. M3 is all right. So M2, okay, I think I'm just forgetting the values. Let me calculate it here itself so that calculation will be pakka. Okay, anyway, so XCM, I'll directly do the calculation itself. So point 0.05 kg, M2 is 0.1 kg plus 0.15 kg. So this all masses will give you 0.05 plus zero point 0.1 plus 0.15, so 5 3. So this will give you 0.3. Okay, so 0.3, and this is 0 plus m2 x2. M2 is 0.1 into x2 is 1. So 0. Okay, so m3 is there also. So 0.15 into zero point 0.5. Okay, so this would give you 0.175 plus zero point 0.1. Okay, so basically 0.30, all right. 0.1, 0.1 into 1 meter, 1 meter, that is fine. So 0.275, and this is 3. Let me just check. 0.15, okay, fine. This is zero point 0.5 x coordinate. Okay, just let me just clean these things. I think I have just messed it up. Let me just, so first one is 50. Let me write with this gram itself. 50, 0, that's fine. M1 x1. M2 x2 is 100 into 1 plus M3 150 into 0.5 divided by 50 plus this 100 plus 150. Okay, so all these are in gram, that's fine. So this will give you 100 plus 750, and this is, so this will give you 300. So 175 by 300 would give you, if I go bring, so 25 into 7 is this, and 25 12, so this will be 7 by 12. Okay, this is the x coordinate. Okay, and y coordinate also similarly, ycm, com, center of mass. So this has, m1 has 0 coordinate, y also, m2 has also 0 coordinate, m3 has this much, this is height of this, so root 3 by 2 into a is 1 meter only, into 150 divided by 300. Okay, so this would give you, so this you can just get root 3 by 4. So this option actually will be the correct answer. So y coordinate will be root 3 by 4, and these are all in meter, and this will be 7 by 12 meter. Okay. All right, so let us go to the next problem. These are all actually I'm taking uh, the problem how to calculate the center of mass coordinates for various mass distribution. In this case, most of the cases we have taken discrete masses, except this one. This we have taken as continuous object. So we'll see when time comes. We'll see continuous masses. For continuous masses also, center of mass has to be calculated. So in this case also, four particles A, B, C, D having masses m. So I have masses. This is having mass m. Then mb, this is 2m. I'm just writing here. mc, it is actually having 3m mass, and this has 4. Okay. So the total mass of all the particles will be 2m plus 3m plus m plus 4m. So this is 5, 5, 6. So this will be actually 10m. Okay, the whole mass of all the particles, summation of the masses of the particles. Okay, I can write, I can take summation I goes 1 to 4. Okay, now if I need this, I can just get it. So these 4 masses are there at the corners of a square, and they have accelerations equal magnitude and with direction shown in the figure. Okay, so I have got few things. Let me write masses. Some of the masses I have got 10m. Okay, and these are all having different, like same magnitude of acceleration, but the directions of the accelerations are different. Okay, so you have to get the center of mass for sorry, the acceleration for the center of mass. So acceleration of the center of mass, how do you calculate? That may you can calculate that force on the center of mass, okay, by the mass of the whole object, like this. Okay, so this is how you can calculate the acceleration of center of mass. Okay, so how do you do that? This one, see. Okay, so then let us find out ACOM can be found out. See, we'll write M1 A1 with a particular sign, actually M1 A1 M2 A2. Okay, with a particular sign, that's why I'm giving vector. There are four particles, right? So this is M4 A4 with the vector sign, and this will be M1 plus M2 plus M3 plus M4. Okay, now look, I'll just take this as x. That means x I cap, this side is having j cap, and this side obviously will be having minus I cap, and downwards it will be minus j cap coordinate. I'll write in terms of coordinate, like in terms of unit vectors, then things will be all right. See, look, this is a square. Okay, so let me just write m1. M1 is actually small, only m1 A1 is the acceleration. All of them has actually same magnitude, but only thing is that the direction is different, so I'll write A minus I cap. Look, this for this one. So similarly for B will be, B has mass 2m, and it is along positive j direction, and for, let me give the sign here. So for the third one, MC, MC actually has 3m mass, 3m, and C is along positive I cap direction. Similarly, for D has mass 4m, but it is actually acting in the negative z direction, and it is actually 10m we have got already. And look, m's will be getting cancelled, and see if I just calculate, like add the ith component, then we'll get 2m, 2m a, the minus sign I cap, oh sorry, this will be plus sign I cap, and j cap, this is minus 2m a into j cap divided by 10m. So this m goes, a will be common, so this will give you 2a by 10, that means a by 5, a by 5, so a by 5 I minus j, a by 5 I minus j, this first option will be the correct answer for this question. Okay, now this question is very interesting, and we need a concept of change in momentum, that is the uh, impulse. Here look, a particle, let me just give you the options here. The options are a is equal to square root of 2p by k, b, option b is 2 root over p by k, option c is square root of 2k by p, and option d is 2 into root over k by p. Okay, these are the options. Let me now read the question. A particle of mass m is moving in a straight line with momentum. So a particle is moving in a straight line with momentum p. Okay. At time t is equal to 0, a force F is equal to kT acts on the same direction. In the same direction, there is a force acting on the particle. So if there is a force acting on a particle, there will be change in the momentum, that is for sure. So during the time interval t, capital T, moving the particle during the time interval capital T, so that the momentum changes from p to 3p. So if I require momentum change, I can find out 3p minus p, that is 2p, will be the change in the momentum. Okay. So here k is the constant, you have to find out the value of t. So look, in case of, see, we know from Newton's second law of motion, dp dt is equal to force. Okay, or we can do integration dp, change in the this. Okay, so in this case, see, I can take the limit. When t is equal to 0, the momentum was p. When t is equal to some other time interval, so actually you go with t is equal to 0 to t is equal to t. This is the limit. So here p to 3p. This is the limit. Now we just do the integration. So dp will be actually becoming p, and it is 3p minus p, that is 2p. That is equal to, so if I do the integration, putting this f like this, and t is equal to 0 to capital T, so this will give you k by 2 capital T square. So we have got 2p 2p is equal to k by 2 into t square. So here t will be square root of 4p by k, and this would give you root of 2 square root of p by k. So this will be the correct answer. We'll have to see. So this option will be the correct answer in this case. Okay, we'll take up one last problem. A piece of wood of mass 0.03 kg is dropped from the top of a 100-meter height building. At the same time, a bullet of 0.02 kg of mass 0.02 kg is fired vertically upward with a velocity 100 meter per second from the ground. Bullet gets embedded in the wood. The maximum height to which the combined system reaches above the top of the building before falling below is what? The options I am writing here. We have to take g is equal to 10 meter per second square, and options are given as 20 meter, then 30 meter, C 10 meter, D 40 meter. So these are the height. It it can go beyond the building. Okay, so let us solve this problem. So how to solve this problem? So it was dropped first. It was dropped. Okay, with from 100-meter height. At the same time, the bullet was fired. Okay, so what is the height? This can be found out. So initially, like, see, you have 100-meter height building. From here, a wooden piece is just dropped. Okay, it will actually move under gravity in the downward direction. That is for obvious reason. It will come down, not so that this collision or the bullet will not get embedded So the place where this would get embedded has to be calculated. So that can be done actually. Initial height will be actually hi is equal to, see how we'll do here is, so suppose the combined mass is small m into hi is equal to the mass of the object into 100. Okay, so this is the combined mass. So initial height will be 0.03 into 100 divided by the combined mass is actually 0.03 plus 0.02 kg. So this would give you actually 60 meter. Okay, now acceleration of the center of mass is how much? Acceleration of the center of mass is actually ACM is the g itself. Okay, g itself, that is 10 meter per second square. This is the uh, acceleration of the center of mass. Now initial velocity of the center of mass, how do you calculate? From the conservation of momentum we can actually find out. So initial velocity, let us take u. Okay, let us take the initial velocity to be u. So initially only this was there, like when it was just dropped, there was, like, I'm just considering now initial velocity of the combined bullet and the wooden part u. This is after combining, and before combining what was that? 0.2 0.02 into 100. This was the thing, and if you solve it, you'll get the initial velocity of the combined center of mass, and this is also actually initial height of the center of mass only. Okay, this is also com or cm we are writing here, initial height of the center of mass. Okay, so mass moment will be always same, so from that concept, and u is actually here this much meter per second, and this is in the upward direction. Now we have got initial height. So we have got initial height of the combined system to be 60 meter. Initial velocity we have got 40 meter per second, and acceleration we have got 10 meter per second. This is obviously downward direction, this is upward direction. Okay, I'll just give sign like this. Now you have to find out the final height. So how do you find out maximum height? Maximum height, maximum height. So maximum height of COM, center of mass, is 8, suppose. Okay, that is equal to, we know this, see, we know this formula, S minus S 0, sorry, uh, V square is equal to U square minus 2G, here H final minus initial, like that we do. So from that concept, so this will be 0 at the maximum height. So we'll get u square 2gh minus 2ghi like that. Okay, so then it will be actually capital H will be u square plus 2ghi divided by 2g. Okay, if you put the values, if you put all the values, then see you get here actually u square by 2g plus initial height. Okay, initial height we had 60 meter, and this is actually 40. 1600 by 2 into 10, so this 10 goes, this goes 80, so it will be 140 meter. Okay, this is actually from, see it was falling down, it was, it came up to 60 meter, and from there it started, so from there 140. Okay, like sorry, this is not from there, ground, from ground itself 140. If it is from ground, it is 140. 140, so that means above the building this will be only 40. Okay, if this is 140, this is 100 up to this, so this will be 40 meter. Okay, so the thing is actually what we have done here, I'll tell you how we have solved. First we have see we have this wooden block, it will actually come down up to certain height as soon as you leave it from there, that height, and when they get combined, at what distance they are getting combined, we have to find out. So that we can do, because the center of mass is actually, see motion of the center of mass, since this thing is like mass moment will be always like m1 x1 is equal to m2 x2, like that. This whole, this is mass moment will be always concept. Okay, so then from there we have found out the initial height. Okay, initial height, and then we know the acceleration of the center of mass is the g itself. Initial velocity we had to find out, and then we had used kinematics. So by kinematics we have come to know that the height, it will be 140 from the ground, so 40 meter above the tower or the building, above the building. So this is how you have to solve problems in this chapter like this, and there are many more problems. These are all, almost all of them were from 2019 JEE mains paper. We'll take subsequently many more problems from this chapter. In fact, this is a very big chapter and also typical chapter. It will be hard to solve few problems from this chapter, but we'll try to solve all the questions from the previous year's paper, so that things gets little bit easier for us. Okay, so that's all for today. Thank you for your patience. We'll meet again in the next class.